National digital twin for critical metals. It's the seed of an idea to make it national, but we're going to demonstrate it within Queensland. Now, digital twins are really exciting technology that have the potential to be used for all sorts of things in industry. They've come from manufacturing and they were used widely in the construction industry. In this case, we're going to be talking about digital twin that's related to visualization of data, which helps enormously with data discovery. And it's probably the world's first digital twin for the mineral resources sector that's focused on things like exploration. So what's going on in the background when it's playing is someone is moving through and driving through the twin environment in real time, but I'll just talk to that slide. A twin is basically a virtual counterpart of what's going on in the real world, and it's connected. So a twin is continuously updating, and the other aspects of what a real twin is it should be coping with and delivering on and processing massive amounts of data. So it's not the sort of thing your laptop can do. It's not the conventional enterprise software that we use to visualize 3D data as geoscientists. This is occurring at scale, and it's continually upgrading. We, with the Department of Resources, as they were at the time, now the Department of Natural Resources, Mines, Manufacturing, Regional and Rural Development, we developed this twin to help them showcase the enormous amounts of data that they have so that industry could discover it and see it in 3D, maybe interpret and collaborate in that 3D environment, and then download to do their own decision making and analysis around. Existing technology that are out there tend to be only 2 dimensions. They don't show all the data. They tend to fall over if you try to load up all the data. And when I was in Anglo American as a discovery manager, we aimed to download as much information as we could for the whole of Australia, and it became a $1.5 million exercise where we had to build servers and dedicate salaries to it. So this frees all that resource up. This twin is in the cloud. It streams the information that you can only see visually from your eyes, so it's extremely computationally efficient, and that means it's not hardware limited. And the critical thing about this twin is, as soon as we built it, we realized not only could you use it to showcase many different mine projects in the one environment, so you could actually compare them together, and we brought in what were known as mineral atlas data sets for individual projects, so we could show them all around Queensland. But we could also bring in other spatial information that's critical for decision making, particularly ESG. And that's opening up a whole new world of development, because traditionally companies will go and look for their minerals data in one location, and then they'll have to go to an entirely different department and a whole series of different portals to download their environmental data, their community data, their lease information, and so on. And that leads to, if you like, divisions in the decision-making process. So it's hoped that with a technology like this, where you can get genuinely a one-stop shop and see the context of your geological information related to what challenges may be in the environment around water and biodiversity and landowner information. If you can see your geological context in that regard, then you can make good decisions about what exploration programs to put in place and how feasible it is going to be for your project to get off the ground, what sort of resource you actually need to discover. And finally, the kinds of innovations that have come from this also include integration with existing enterprise software like Esri, something known as Cesium, which is a relatively well-known 3D visualization platform, and we can put this in XR environments, so Oculus Rift goggles and immersive TV visualization rooms and so on. And that's it. Thank you very much.